And welcome back. We're at our last section of the 2.1 rates of change as limits for your first section of calculus to be done. So I'm really excited. So let's go ahead and take a look at our first example. For this example, it says we're going to go ahead and draw the graph of f. So we're going to go ahead and do that. Then we're going to determine the limit from the right for this c and determine for the left. And then we're going to do a writing. So we're going to determine what, does this limit exist, and if so, what is it? So let's go through this a step at a time. So here's our function, piecewise function. So the way that I want to go ahead and do this is I want to do each piece one at a time. And I start up my key points here. So starting me at x equals 2, I want it to be 2. So x equals 2, 2. And I always want to remind myself, yep, I did that, check. So they say when x does not equal 2, okay, so let's take a look at that. When x is less than 2, it's here. So this is just becomes graphing of a line. So I start and I would plug in 2 into here, and I'd see 3 minus 2 is 1. So at 2, it's at 1. It's going to have an open circle, and whatever I'm less than it, I have a slope of negative 1. So I'm here, here, here. I go ahead, draw my line. Alright, and then the next one is whenever it says here I am greater than 2, so again I would plug in 2, again I would have 1. Alright, so I have 1, it's going to be a hole, so again I have my hole here, so I might as well get another color. Here's my hole. Okay, checked off on that one. And then I'm going to go ahead and see that I have a slope of 1/2. Okay, so a slope of 1/2. So I go up 1 over 2. Up 1 over 2. Alright, so there's part A. I drew my graph. Next it's asking me to determine my limit from the left and right of c, but what is c? Well, c is over here of x equals 2. So I want to determine my limit as it approaches 2 from the left and 2 from the right. Okay, so as I'm approaching 2 from the left, so here I am, I'm going this way, 2 from the left, oops, so the limit as x approaches 2 from the left. So 2 from the left over here. Find out, hey, my intended height here is 1 of my function is equal to 1. Then I find out, well, what's the limit as x approaches 2 from the right of my function? And I find out it's also 1. That's my intended height. So now part C is asking, does the limit of f of x exist as x is approaching 2? Okay, if so, what is it? Well, what I'm seeing here is my intended height for both the left and the right get to be the same place. Because I have that, all right, I'm going to go ahead and say, yes, my limit does exist. All right, so for part C, the limit as x approaches 2 of my function is equal to 1. Okay, if so, what is it? Did it? If not, explain. Well, I want you guys to go ahead and explain right here. I want you to know or tell me in words, why is this true? Okay, why is it true? In words, just type it out real quick. I'll be right back to do the next one. Alright, hopefully you got the explanation. We'll take a look at it. We'll talk about when you guys get there to class tomorrow. Here we go. Last one here says use the product rule. Using the product rule. Okay, product rule, It says here solve graphically that the function in figure 2 suggests that it has a limit and exists to be about 1. Okay. We're going to use the same type of a thing. What we're going to have here is I got to take graphically, I take a look. Well, as I'm coming from the left, Okay, the limit as x approaches 0, so I'm interested in what's happening here. My intended height does look like to be 1. My intended height also looks like this appears to be 1. So graphically, that's all you'd have to show, is that, hey, from over here, I'm getting closer and closer to 1, and from the left, I'm getting closer and closer to 1. So there I am. The hard part is doing the confirming analytically. Okay? So what you need to remember is that what makes tangent. So I can go ahead and summarize. So when it says analytically, that means algebra. So yay, algebra. So I come here and say, well, the limit as x approaches 0, I can rewrite tangent as sine over cosine all over x. Well, I can then break this apart because of what we know about our complex fractions and be able to say, well, this is equal to the limit of sine x over cosine x times 1 over x. Don't forget as x approaches 0. And this is where I'm going to know what's happening in the future. I'm going to kind of set this up a little bit differently. So I can then say that this is then equal to the limit as x approaches 0. And I'm going to recombine these in a little bit different way. I'm going to say sine x over x times 1 over cosine of x. All right, great. So what does that mean? What can I do now? Well, with the many different rules that we had for limits, one of the things that we can do is I can break this limit expression by saying the limit as x approaches 0, that this is equal to that of sine x over x times the limit as x approaches 0 of 1 over cosine of x. Now hopefully you guys remember all your unit circle stuff, and what you should be able to see here on this one is when I put in 0 for x, I get cosine of 0. Cosine of 0 is 1. So this part of my limit, okay, becomes 1. This limit, this piece of my limit is equal to 1 times, now I have this funkiness that's over here. If you all are paying attention, okay, right? If I put in 0 here, sine of x is sine of 0 is 0, all over 0. I have 0 over 0, my snowman. There's a hole. Great. Now I'm going to be honest with you. This is one limit that you must memorize. This right here is a memorization. If you want to come and see the actual proof of this, you're going to have to come in. You can come in after school or something of the sort and tell me beforehand. I'll get the proof ready. We'll rock it out together. Okay? But for right now, what you're going to need to do is just trust me on this and say, you know what? This limit right here, and if you type it in your calculator, you'll see this, but this also goes to 1. So now I have 1 times 1, which is equal to 1. So all that work here, just to show what we already saw in the graph below. Okay, you won't be asked to do that often, but I highly, you need to become more, skilled with the algebra. And it's just another way of pumping that iron, right? Getting your algebra brain muscles working. All right. Well, I look forward to the next time. Again, come ready with questions, and don't forget to summarize what you've learned so far. All right. Bye. Oh, there's your homework.